Hey everybody, it's Nigel here, back with you with Nigel's Land Rover channel, and this is another video now we're going to be doing about gearboxes. So in this video we are going to talk about parts. We are going to get the output shaft fitted into the back of the gearbox. We're going to get the transfer box fitted onto the gearbox. I'm also going to do some clocking and show you how the transfer box runs with the gearbox, and that's going to affect this, what we're going to talk about here, this shaft. So in this video, it's going to be the final time I will talk about this issue with the output shaft and this casing that goes between the gearbox and the transfer case. It's a big subject. It's talked about a lot on Defender2.net. There's a lot of opinions, and there are a couple of aftermarket solutions out there. So I'm going to give my opinion as a time-served engineer on what I think is going on with these things and about their design and everything. And I'm also going to talk about the options you've got out there from Ashcroft and from Loft. I can remember the name now. Loft. I've spoken to Luke at Loft Clutches, and I've spoken to Dave Ashcroft. So I'm not talking behind anyone's back, and everything I'm saying is totally based on my opinion, and my opinion only. No more than that. As I say, I've spoken to Luke and I've spoken to Dave. They have opinions. I'm not going to go through that because that's their opinion and it's not fair for me to convey their opinion. Right, so basically the first thing we talk about is this shaft. Now, what Ford did, for those that don't know, I mean, if you did know, just fast forward. Basically, you've got the gearbox, the MT82, which is the gearbox out of a Transit. It's also fitted to a Ford Mustang. And what they did, they modified the rear casing. They probably changed the gearing as well, but they modified the rear casing so that it would take this intermediate casing, and this casing is designed on this face with dowels to fit the back of the gearbox, and then on this face with dowels to fit onto the transfer box. Now, as you'll know, if you've got an old R380 or an LT77, then the transfer box bolted directly onto the back of the gearbox, and a shaft came out of the back of the gearbox that looked very much like this, that drove the input gear on the back inside the transfer case. Well, Ford didn't have that luxury because they didn't have that form on the back of the output shaft of the MT82. What they had was a male spline and a female thread that a yoke would normally go on to drive a prop shaft. Okay, so rather than completely remake the whole shaft, because it's a Geartrack box, and I don't know if Ford owned Geartrack at that point, I think they do now. Basically, what they did, they came up with a design so that they could still use the LT23 or LT230, sorry, transfer box in the Land Rover Defender, but also be able to use the Transit gearbox, okay, because they no longer wanted to use the R380. So a lot of people say what they've come up with is a crap design. I actually think what they've come up with is a good design, and bear with me, I think it's a good design as long as everything else is in place. And when I say everything else, I mean this shaft, this spline here needs to be greased, and the components need to be in line. Obviously, when you've got the transfer box going onto here and the gearbox going into here, then you've basically got chances of error. So you've got the shaft coming out of the back of the gearbox. If the input shaft for the LT230 is over here, then obviously that's no good. And as this is going round, it's got to basically be whipping around like this. And what's going to happen, it's going to put all the load into this spline here, and it's going to wear out. Right, so what is happening? You've got cases like mine, and there are quite a few, where I've stripped it down and it's absolutely fine. Okay, this was coated in grease. It was heavily coated in grease. I've since washed it all out. Okay, so this was heavily coated in grease, and you can see, I'll show you close up later, but you can see that these splines are perfect. There is next to no wear on them whatsoever. There's a slightly polished mark, and that is it. Okay, so that's all good. So, and I know that because I've clocked it, I know that my gearbox is all in line and everything. So with a greased shaft and the gearbox in line, there's nothing wrong with that at all. Okay, 16,000 miles, mainly road miles, and it hasn't worn. So, and it's never clunked and knocked or anything. So if you think about it, the spline going into the back of a CV joint in your common car, you know, in the back of your Ford Mustang or your front of your Fiesta or whatever, every car's got them pretty much. You've got a spline going into the back of the CV joint, which has got grease on it, and there's a circlip holding it in there. They don't wear out. Okay, I've never known one of those wear. I've known the spline on the other end strip out, but I've never known those splines wear. It's the same as the spline on your clutch. You've got a spline going into your clutch plate, that's greased generally, so that the clutch can slide up and down. They don't wear out. They're absolutely fine. Basically because everything's in line and they're greased. So if these are dry, corrosion sets in and they fret against each other, the corrosion becomes abrasive, hence they just wear out. If they're out of line, even if they are greased, they are going to completely mash each other to pieces. Something has to give. The shaft in the back of the gearbox ain't going to give. This spline on here, the spline in here that goes into your gearbox over your shaft, that ain't going to give because there's a huge nut in there which is torqued up to 180 Newton meters. You're going to see me in a minute doing this up and you'll see just how tight it is. So that's not going to give. You've got great big Timken bearings, like huge Timken bearings in the input shaft in the LT230 transfer case. So that's not going to give. This shaft goes into a solid gear, which is your input gear on your, that's not going to give. So the only thing that's going to give is this spline. And that's why they go, in my opinion. If they're not greased and or if you've got run out in the gearbox. Now, as I say, I've spoken to Dave Ashcroft. He's sold many thousands of his conversion. And basically what he's done, he's taken this and give it an oil feed. And it's got O-rings in there which seal. So it's got a, it's not pressure, it's not like pumped in, but it's oil that's splashing around in the back of the gearbox is allowed to go into there, and then that can keep the spline lubricated. And he hasn't seen, well, he's seen very, very few issues. And what he's told me is when he does see issues, he sees fretting. And what happens is because he's got O-rings here, he's got O-rings on here, sorry, here, and he's got O-rings on here with an outer cover going on that basically seals it all in. It's like a cup that goes over this and kind of go and seals the oil in. Now, what he's told me is seen fretting. So obviously if there's fretting, it means there's misalignment. So something's misaligned, and as it's going around, it's pulling it over one way. So that would explain why the failures are there. And as I say, in every failure he's had, and there has been very few, I believe it's less than 10, I can't remember, but in every failure he's had, there has been fretting. Now, as I said, I'm not going to discuss opinions. I'm only going to discuss my opinion. But it would say to me that if every failure that the Ashcroft designers had has seen fretting, that would indicate misalignment. Okay. If we talk about the loft shaft, the loft has basically made a solid shaft. Okay, solid one-piece shaft that takes place of these two pieces. Now, I will give you my honest opinion, and my only criticism of that shaft, the only criticism I have, is the fact that this nut in here is done up to 180 Newton meters, and when you get the loft shaft, it's done up to 56. You've got a bolt going right through the whole lot, and it's done up to 56 Newton meters. Having said that, everything that's on the back of that shaft that's coming up against here, so this is clamping onto the back of the bearing in the back of the gearbox. Then you've got the reverse gear synchro hub. Then you've got the reverse gear bearing. Then there's a couple of things, and you're actually pulling up against them, and they're all pressed on. All right. So once you've had this on at 180 Newton meters and everything is pressed up, do you need 180 Newton meters to hold it all in place? Probably not. So my only criticism of that shaft is the fact that that bolt is done up to 56 Newton meters, but he has sold a great number of them and has seen no failures. That's why he gives it a lifetime guarantee. So obviously there isn't an issue, and it's on some pretty high output applications as well. The other problem with that shaft is if you have got run out, something's going to have to give, and a solid shaft is going to be stronger than that spline. Now the shaft, I say solid, it's hollow so the bolt can go through. So one would assume, okay, one would assume that in time, if you have got run out, the shaft will break because it's hollow. It has to be the weakest part. You've got the huge shaft and the big bearing in the back of the gearbox, that's not going to give. You've got the huge input gear and the huge bearings in the front of the transfer case, they ain't going to give. So the only thing that's going to give is the shaft. So my advice, okay, this is my advice, and as I say, totally based on my opinion. If your truck, if your Land Rover is going through these like Sunday dinners, and I know there are some out there that are getting like 17 to 20,000 miles on these and they're wearing them out, you need to check the run out between your two parts, because this is living proof. This has done 16,000 mainly road miles and it's got nowhere it was greased, and I've got no run out. Well, I've got a very small run out. So that's living proof that that works. So if I decided to get the Ashcroft or the Loft, I would be absolutely fine and they would last probably forever. Okay, there's no reason why this shouldn't last forever. If it's greased, there's no reason why it shouldn't. However, if you are one of these that you've got 100,000 miles on your truck, you've got a clunking, you've taken it apart and this is all rusty and it's not greased, get the Loft one, get the Ashcroft one. I think you'll be absolutely fine. If you've got 100,000 miles out of one of these, I think you're probably absolutely fine. However, if you're one of these that's got the 17 to 20,000 miles or 25,000 miles and they keep going, I don't think anything is going to be any good. You can replace it with this and it'll wear out again. You can replace it with the Ashcroft one and it's going to wear because it's pulling on the O-rings. And if you put the Loft one in there, something else has got to give. So up to you. So that is my advice, and that is the advice that I've spoken to Luke a lot, and I've conveyed to him. You know, that is what, and I suggested to him that he ask his customers if they're replacing this because they keep getting these wearing out every 20,000 miles. I wouldn't personally risk putting a Loft one in there because I don't know what's going to give, or what's going to. It could just wear everything out. You know, you just don't know. But again, as I say, this is all my opinion. So enough of that. I've waffled enough about this. So let's get it all put together, and we'll go from there. So guys, welcome back. And today I've been painting engine mounts, as you can see, and other bits and pieces. And I've also been working on this. This is the gearbox with the transfer box sat on top, and I've got a clock in there so I can actually clock the transfer box relative to that gearbox. So let me show you what I've done first. So it's all hanging here on, it's all bolted together, but it's just suspended on here because it wants to fall over, obviously, because it's sort of top side heavy. So we've got no input gear here on the transfer box. I decided to leave this out so I can assemble it without damaging the seal. And then what I can do is slide the actual the input gear in and then pull down everything. It's all shimmed and everything ready to go. So down in there, if you look, we've got a clock on a little mag base. It's the clock I always use, the little red mag base, and it's sat on top of the input shaft. So if I place the camera down here, you will see, I'm clocking the seal diameter, which is going to be machined in situ with the bearing diameter. So if I get the camera so it's kind of looking down in here and I get the light a bit better for you, and then we'll focus on the actual clock itself. I can get down on my hands and knees and I can turn the input shaft, and then I can make the clock go round, and you can see how much run out we've got between the gearbox and the transfer case. You can see that on mine, it's roughly 10 or 12 thou, which isn't bad at all. Now if you want to go back and pause that video and watch it slowly, you'll see what you need to do is look at it across in 4 places, so sort of 1, 2, 3, 4, sort of 12 o'clock, and do it like that. If your gearbox is actually still in the car, you may get away with this, I don't know. But what I have found is I have got a little bit of play on the dowels, just a couple of thou. I'm able to tap the transfer box about to get it slightly better, and it's certainly on mine. If I tap it that way and that way, it's better. So but it's literally, you know, a thou or two. So there you go. Now you can see how that works. Now, just to put some words around this, put some meat around the bones, if you like. Basically, this is probably why my output shaft has lasted so well, because it's only got that small amount of error. Here we go, guys, just to give you a better idea of what it is I've done. You can see down in there, we've got the gearbox here, just so you can see what we're looking at. That's the gearbox, and then we go down into the end casing, and you can see down in here, we've got the clock on the mag base sat on the shaft. So as the shaft turns, the clock goes with it. The clock doesn't have to be on dead center, because whatever it does, it will always form a perfect circle with the shaft. So that's basically, it's that easy. So if you have got a little mag base and you've got your gearbox out, then you could do the check. Okay, and just for those who don't know, you've got a dowel here, and you've got a dowel which is pressed into the, this is quite a loose one, this one. It has got a couple of thou player, that's probably where the movement's coming from. And you've got one here which is pressed into the actual transfer box. There's the transfer box there hanging on the rope. If you want to see the balance points, there you go, you can see there and there, and this is there just to, it's not really doing much, but it's just to save it because it could just flip over and flip out, so that stops it doing that. So there we go. So I've got to now get the seal in the back of the gearbox, get the output shaft in, and go from there. Okay, so here we are now with the standard input shaft, or output shaft should I say, input shaft for the transfer box, output shaft for the gearbox, whatever you want to call it. So basically, two parts going together. This has got to be pressed onto a spline in the back of the gearbox, and then this is going to go in there, and we've got a snap ring in there to hold it. So before we put that in, we've got to get this bolted onto the gearbox and get some grease in there and everything. So one thing I did think about was I wanted to make sure this went back together the same as it came apart. And if we look on here, if I can get this in the lens, where are we? If we look on here, we can see there are some shiny areas, particularly looking here to the right of the circlip. You can see there's some shiny areas where it's been contacting, and then all of a sudden there's an area, you see, between here and here it's dull, and that is lining up with these slots, okay, in the actual hub. And if we look at these slots, we can see that they are cut in there at random, and you can see, if I can get it to focus, you can see that, for instance, on this one you've got one half of the spline, it's sort of cut through the middle of the slot, yeah, and the same on that side. And on this one we've got a complete spline there, and it's sliced down the side of it. So we can look at the markings on here, and we can look at the markings on here, and we can actually see which one goes in where. Because basically where you've got this half where it's cut through the middle of the spline, what you will see is, where are we? You'll see an area here of dull, and you'll see that on this one, if I can catch it in the light, we will have it, come on camera focus, we will have a shiny bit on one side only. So I know that that one goes in there. Whereas the one where the is round one more, so that goes, I've got a yellow mark on it just to help me during the filming, but basically we can see which way it goes. Now on this one here you can see we've got a complete spline, okay, because it's cut down the side of it, so therefore we will have a polished area on both sides. As you can see, if you can see, I don't know, but if you look here in the light, come on, where is it? You can see we've got a polished area there above the snap ring. Okay, so that was how I identified it, and that's how I'm going to make sure it goes back together exactly the same as it came apart. Okay, so we're back at the gearbox. I've knocked the seal in. I had an aluminium ring. I just pressed the seal in, so that's in there now. It's nice and flush with the surface. So got this hub, made sure this face is spotlessly clean, and made sure the face of the bearing down inside there is spotlessly clean. The manual says to heat this to 100 degrees. I don't think I need to, because mine is quite a nice fit. So I'm not going to bother heating that. And I can basically just tap it on like so. So I can then use the bolt to pull it on the rest of the way. So what I've got to do now is lock this in place. Okay. So what I need to do is, I've got this little bracket here and a couple of aluminium feet. So what I can do is bolt that in there, and then bolt that in there. Just pull those down with an Allen key so they're tight, so we don't rip the threads out. Now I should be able to with this hub just basically pull it down. Now I haven't put any thread lock on this bolt yet, which is what you're supposed to do, but they tell you to do it for 210 Newton meters. And then let's just get this aluminium block. I'm going to put this aluminium block in here, which fits beautifully in that gap, and I can swing it round to there and it will hit that and stop. So now I can tighten this bolt. As you can see, the problem I'm going to have now is the gearbox is going to start moving. So I've got my tool here, which, as you know, I use for holding things, and I'm going to put a bolt through this one. I think I'll put it here. Just bolt that into there, and then a spacer on this one. In fact, I'm going to move it so that it's actually the other way and it's up against me. And then what I can do is jam myself into it while I tighten everything up. Now I'm going to go on and do this with the camera off because you don't need to see me launching this up. Okay, I'll just quickly show you how I did this so you get an idea if you want to do this yourself. I've got that bracket there bolted on. I've got a piece of old carpet wrapped around so that it doesn't split me in half. And then got the hub locked here, as you can see. Get the torque wrench on there. Got some thread lock on the bolt, and then just basically just pull it like that. So got this up against my stomach, and I can just do that up like that, and that's it, done up without groveling around on the floor like I did before. Okay, so that's all done. All the brackets are gone now and everything, so we can start assembling. I just want to show you these two items here. This is TDL 500080, and that's a snap ring for the that's a new snap ring for the actual spline that goes in there. And then here we've got this tube of grease, anti-seize, and this is part number IYX 500050, and it's called O-ring. Okay, now I've just gone onto the LR Workshop channel, which is brilliant, and there is indeed an O-ring in there, and this is actually for Range Rover, Discovery 4 and all that sort of stuff. So obviously it's not intended for this, but it's the same grease, so the O-ring can go in your spares bin, and the basically just use the grease. I'm going to slather it in there, you can't have too much in there, so let's get that done. Alright, so we've got the grease on it. It's a special grease. You can see I've got plenty on there. I've also put a bit around the inside of the hub as well. So I'm going to get this on now and get these splines lined up, as I said earlier, to make sure it goes back in the same place as it did before. So we can see, in fact, if I grab a torch, it makes it easier for me to see. I want to see that it goes in the right place, because I can see in the light where it's rubbed and where it hasn't. That's one spline out. That's it there. Okay, you can see as I push it down, all that grease is working its way around those splines. We need to make sure it does work around them, because remember, nothing here is sliding about or moving or turning. It's not like gears, so the grease won't sort of find its own way around the spline. You need to get it in there. So just check once again that that is in the right place. Where did I put the torch down? Just check again that it's in the right place. Yes, it is. I can see it's rubbed on that side and not on that side. So that's right. So we can, I'm guessing I should be able to just, there we go, just push it in until that snap ring is in place. Is that it? I think that's it. Yeah, I can't pull it out, so there we go. And you can see the grease has gone all the way around there nicely. So I'm just going to put some more. This syringe is weird. The hole on the end is about 1 millimeter in diameter, so you're really struggling to get the grease out. I'm going to put plenty on there. And as I say, in my opinion, and it is my opinion and my opinion only, I don't think there's anything wrong at all with this design, as long as it's greased and as long as everything's in line. I think I mentioned before, there was a guy on Defender 2, I won't name him in case he doesn't want to be, but he actually took his gearbox apart at 250,000 miles or something, and it was absolutely fine. He'd even bought a new assembly to put in there and didn't bother because there was no wear on it whatsoever. And he said it was well greased, so there we go. So that is that, guys. So now what we need to do is put the rubber on. And we have a rubber seal. See here, it goes on. So that's just going to slide over there. That's going to help to keep the grease in. And then we've got this plastic piece that goes over that holds the seal in place. So that's going to slide over like so and clip on at the bottom. Need to make sure the legs go under. Yep, so they're in. And then, believe it or not, this is one part of the design I do think is a bit dubious. I hold all this together with a cable tie. Now, that cable tie is a bit too wide. Got this one here. The best quality cable ties you can look for, they've got a steel or a metal insert in them. I don't know if you can see in there. There's a metal tang in there, and they are the highest quality cable ties you can get. So if you can get one of them, that's the ones you want to look out for. Okay, so make sure that's in the right place. Yeah, it's in the grooves. Pull that good and tight. Okay, and then we're just going to cut the end off. Just one thing, guys, while I'm on the subject, if you saw my gearbox build, you would have seen me fit this, the actual selector, and if you notice, I've got the bolted the other way around now. The nut should be at the top. It's supposed to be fitted left to right like that. I had it the other way around. I was looking at it, I thought that bolt was very close, or the nut was very close to when the cable tie goes around. So make sure you turn it around, so if you've done the same as me. So the nut needs to be facing the top. And I'm also looking at this, if the cable tie should come off, I don't know how you know that it has, but you could probably just take the gear linkage out and you'd probably get down through here to get into there and actually get that changed. So anyway, let's get on now and fit the rear seal. Oh, while I think of it, hello Steve, hello Tracy. Got the casing here now with the dowels fitted. Okay, this is something I was looking at that could be a cause of error. If this dowel isn't fully inserted in there, it could rock, and that could give you a misalignment issue. So something might be worth checking if you've got issues, if you have problems with alignment. So that goes on like that, and you can see those dowels are a fairly good fit. They're a nice sort of sliding fit. They're not too tight at all. Just looking here, that cable tie comes mighty close to that casing. In fact, it's actually rubbing it. I'm going to see if I can find something a bit more slimline. Okay, so I fitted my last remaining metal insert cable tie, and I pulled it tighter with pliers, so I've gained about 2mm clearance now. So I'll show you in a minute how close it actually is. So we get this cover on, the casing sat down. And if I grab the torch and the camera, I should be able to show you down here. Get some light down in there. You can see down here we've got the end of the cable tie. Where is it? There it is. Okay, the end of the cable tie down here, you can see it if the camera would stop focusing on the shaft. And then when it goes round, it's if I just tap the camera, it'll focus down there. Here we go. You can see how close that is down there. It's very close indeed. So there we go, something to look out for. Don't use too big a cable tie. So now we've got to fit all these bolts in here. There are 10 bolts, M8 by 30, I'm guessing. Yeah, 30. Just check just in case you're hunting your box. Yeah, they're 30mm long. And I noticed a couple of them were rusty actually on the threads. You can see here a couple of them are rusty actually on the threads, which I thought was a bit of a surprise. Come on, camera, focus. There we go. So what I'm doing is basically I put a coating of oil on them. So I've just brushed some engine oil on them, basically, just to help them. I don't know why they would be rusty. Maybe it's a particular point where water splashes up off of something or other, I don't know. But basically, I don't want to be having rusty bolts on my Land Rover, thank you very much. So I'm going to get these done up. I don't think you need to see this, do you? 25 Newton meters, and then we'll be back. And there we go, there's the casing on, and as you can see, right here and here I've got the dowels in as well. See, there's dowels in there. Now we've got to get that up onto there. So this is going to be fun. So I'm going to do that off camera because it's not going to be much point in you watching me lift this on and everything. So I'll get this on there, get it bolted down. We've got to put thread lock on the bolts, which I've got down there, and they're all going to be torqued up to 45 Newton meters. And there we go, guys, it's together. And if I go and stand next to it, I think you classic Land Rover boys will agree that is one bloody long assembly. It's huge. Right, so what we've got to do now is put the input gear into the top of the transfer box. That's going to go in, where's my finger? It's going to go in here, bump in there. You don't have to do it this way. I just decided to do it this way because I thought it would be easier to put the transfer box onto the gearbox without that gear in there. And I'm glad I did decide to do it that way now because it enabled me to go in, as you saw earlier, and clock everything up. So let's get that together. Right, so here we have the transfer case input gear on the bench. This is the gear that drives, so you've got splines inside here where that shaft that we've looked at, the output shaft, goes into, and then that is what drives the vehicle along through the intermediate gear in the transfer box. So let's get that dropped in. It goes in that way up, and then this bearing cover here, which is shimmed, goes on there. Okay, and then this plate here, which is your top plate, goes on there like that. We've got to put silicone in there, bolt everything down, and then we're good to go. Okay, so we can drop the bearing down in there over the shaft. Just going to look down this side, make sure there's no debris or anything. Everything's looking good, so that's all cool. So this is going to go down in. It's going to mesh with that gear, and I don't want to drop it because I don't want to damage the bearing. And there we go, that's down in, just like so. Job done. And I am just going to put some oil in there because I want to make sure that from the outset, this actual spline inside here on the output shaft has some lubrication, because that is a failure on the earlier Land Rovers. If you notice in here, this gear has got holes in the side of it, you can see, and they were put there to splash feed the spline, otherwise they would wear out because of no lubrication. So there we go. We'll get some silicone on there now, get the bearing plate on, then we'll get some more silicone on and get the back plate on and get it all torqued down. Alright, so I'm going to use some Hylosil on here. I've made sure the faces are clean on here, so I'm going to use Hylosil. This is the one that Dave Ashcroft recommends and supplies with his sets, so if Dave Ashcroft recommends it, it must be right. So, right, I'm going to make sure, just a quick tip, when you clean these nozzles out, make sure they are clean, because if you've got any hard lumps in there, then you will, you may impair the sealing. You'll end up with a lump. And the same here, you can see in the neck, even though the lid's been on, there's some hard silicone in there. So I'm just going to make sure that's all gone, because you don't want hard lumps of silicone in the joint. There we go. Put that to one side for now. So I'm going to put all these on, put the ring of silicone around here, put a ring of silicone around there, put it all together, get it all together, and then take the bolts out one by one and thread lock them, because they're through holes into the gearbox. So if we don't put thread lock on them, oil will leak out around the threads. So what I'm going to do is put a small bead around here, like so. Okay, and then around each bolt hole, or each hole should I say, not just bolt hole. go. And then, just for extra bit of security, we'll just put some around the outside edge. Just like so. And then we can take that over and drop it on. Right, so when it comes to this back plate, make sure you get it the right way around. This side has all what looks like ejector pin marks in it, and it also has the writing. That's going to be out. Make sure you got this face in, which is nice and flat. And again, we're going to go around this one, and we're going to concentrate on the around the edge first. All around the edge, like so. This is like a, I don't know, a 2mm bead. Just like that. And then, I'm just going to get a bit more there, it's a bit thin there. And then I'm going to go around each bolt hole, just like so. Here come the flies. Flies seem to love silicone. Probably because of that vinegary type smell. Okay, so just make sure you have got a decent bit around here. You don't want any sort of dry patches really. There we go. A little bit more there. And that should do us. So we're going to drop that on. And there we go, guys. She's off being vertical, down horizontal. And there we go. Give you a quick walk around. See how it looks. I've put these brackets on. Unfortunately, you didn't see me holding this on because this bloody iPhone, this thing here, iPhone 10, worst iPhone I've ever had. Yeah, iPhone XR, it's absolute crap. The button for on, it must be so sensitive that you sort of accidentally touch it twice or something. So I end up filming what I don't want to film. I did the same when I put the cam covers on the engine. It's just rubbish. So this is all on there now. They're all thread locked. I did them up to 30 Newton meters in the end. You can see we've got a nice bead of silicone coming out as we have here and everywhere else. So all good. That nut there has been put on loosely because there's an earth strap that goes on there. These two brackets, they're all painted up and everything, as you can see. They're put on where they were before. So that's why the stud nut's there, and that's why the stud nut's there. And this one's just a bolt. And that's basically that, guys. You'll also notice that I still haven't got the reverse switch in because it's a plastic thing that sticks out here and it's so vulnerable. I won't put it in until the gearbox is actually bolted into the chassis, which will probably be the next thing I do. So there we go. It's all good. Hopefully it'll all, let's see if it turns. That must be in neutral at the moment. Let's put it into a gear. There we go. So there we go. We've got forward motion here, we've got motion there, so there and there. So at least it all works. Get it back into neutral. In fact, I'll leave it in a gear actually, it's probably better to be in gear. One thing to be careful with these MT82s, if they are like delivered, if you buy one in transit, not in a transit, but if you buy one and it's delivered like in transit, if they drop them or knock them this way, otherwise drop them on their front, it can actually lodge them into two gears, so you need to be wary of that. And the way to get it out is to take these plugs out and get it back into gear. If you look at Mustangs and stuff on YouTube, you'll see stories about it on there. So the beauty of the Mustang is with the Chinese gearbox, all of the detents are like this, so you can actually pull them out and push them back in, whereas these horrible things, you have to drill them out and destroy them. So anyway, there we go, that's it all together. And I'll do a picture here now, like this. Here we go. There we go, like that. So you can do a before and after. I'll see you later, guys. Thanks for watching.